Hello students, today we're going to talk about the distance formula. Now, the distance formula is used to calculate the distance between two coordinates. So there is a formula for this, and we could just say what it is and you could follow it. However, I'm a firm believer in learning where things come from. So let's start at the beginning with something called the ruler postulate. The ruler postulate is a very straightforward concept. Let's pretend we have a ruler and it's got these points on it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be 0, this would be 12. If I have 2 points on there, here and here, this would be 1, 2, 3, 4, 5. A is at 5, 6, 7, 8. If I wanted to know the distance between A and B, first of all, I could just count 1, 2, 3. But second of all, if these were huge numbers that were hundreds of units apart, I would have to do some math to figure that out. So the distance between A and B would be the bigger number minus the smaller number, and that would give me 3. Now, the ruler postulate is all well and dandy as long as we're dealing with points that can be connected with a horizontal or a vertical line. However, that's not always the case. So, what if we had another case where we have 2 dots, 2 points, A and B, but this time something like 3, 5, and 8. I'm sorry. Let's make this work out nice. 7, 8. I want to know the distance between those points on the diagonal. Well, here we can start using the Pythagorean theorem. So in order to use the Pythagorean theorem, we would say a squared plus b squared is equal to c squared, where a and b are the legs of a right triangle and c is the hypotenuse. But this isn't a right triangle. We would have to make it a right triangle. We would do that by creating a horizontal component here, and then creating a vertical component here that makes a right triangle. So looking at the horizontal, if I just look at the x's, this one starts here at 3 and it goes all the way up to 7. So that means this one right here is 7. So if I use the ruler postulate here on this horizontal piece, I know 7 minus 3, this horizontal piece is 4. Looking at the vertical piece, it starts at 5 and it goes up to 8, so I know that the vertical piece is 8 minus 5, this piece is 3, and then this piece is the hypotenuse, so that would be c. So now I can say that 4 squared plus 3 squared is equal to c squared, or 16 plus 9 is equal to c squared, 25 is equal to c squared, and then if we take the square root of both sides, we would get c is equal to 5. Now, for those of you who remember Algebra 1, you would say, well, anytime I take the square root of something, it produces both a positive and negative answer. That's true, however, since in this case we are talking about distance, there's no such thing as negative distance, so we assume that the positive number is the correct one in this case. Now, this is not a formula, this is us drawing a picture and then coming up with the answer. And of course you're welcome to do this. However, let's talk about using the formula. What if we had to find the distance between 2 points, and for the sake of coming up with the formula, let's say I wanted to find the distance between x1, y1 and x2, y2. Well, in order to do this, we would want a squared plus b squared is equal to c squared. Now, if you remember, for us to find a squared, we subtracted the two x's to figure out the distance between them. So that means right here, instead of a, it's going to be x2 minus x1 squared, plus, to get the b value, we subtracted the two y's. So that would be y2 minus y1, and that would be equal to c squared. Once I add those together, in order for me to get the distance, I would take the square root of those sides. So I would get the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses equals c. And this is where the distance formula comes from. It's actually just a modified version of the Pythagorean theorem. So, in order to find the distance between 2 points, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's do an example. Find the distance between 1017 and 4035. So I'm just going to label this real quick. This is x1, this is y1, this is x2, this is y2. Now I can say that the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Plugging in values for that, I'll have the square root of 40 minus 10 squared plus 17 minus 35 squared. So I know I've got the square root here. 40 minus 10 is 30 squared plus 17 minus 35 is negative 18 squared. I'm going to go ahead and use my calculator on this one just to make sure. 30 squared is equal to 900 and negative 18 squared is equal to 324. So I've got 900 plus 324. Oops. 900 plus 324 is equal to the square root of 1224. Then use the calculator one more time. The square root 1224 equal to 34.98571136900718. So I'm going to say that the distance is approximately 34.99.